say max amount. You could have monthly bill. And because this is a really simplified example, we don't really have to worry about other tables such as, bills and invoices, and all that other junk. We're just keeping it simple here. And let's say this is how we structured our database, and we want to make it more user-friendly with a join to where we join information across the table. Because we don't want to have the customer ID for the card. So we create a join, and we make this new generated table. I don't know why I made that like circle, but oh well. And within here, we could say it's the card customer. For example, it doesn't really matter what we give the title of the actual table. And what we're going to do in here is we decide which columns we want to take. Well, the first thing, we always start with the ID, because that's how things are going to be joined. And we don't necessarily have to return that ID within our table, but we need to think about it because that's how we connect the tables. So, generally, the ID is just for the database's sake. It's usually not something you use outside of the database. It doesn't have any real-world value, so we usually don't need to record it in the join for a viewed application or whatever we're using this for. Now, if you're the database administrator and you want some more presentable tables like this, but you want to keep the IDs in there, that's fine too. But we're not gonna return the customer ID. There's no need to. It's just a number. But since it's in both tables, if we did join it down here, it would only be in one column. So we would have, customer ID. And that's going to take the combination of these. We're going to have the customer ID, like let's say 62, and then card ID be like 7, and then customer ID 62, and card ID 8. So that's kind of how that would work. But we're not going to return those. So what we're going to do is we're going to return just the first name, last name. And we're also going to return the, let's add another column, amount paid. So basically that's saying like how far they paid off their credit card bill. Let's say you borrowed $10,000 and you owe $6,000 and you've paid back $4,000 so far, just to see how far people are getting to paying off their bills. And like I said, this is a very simplified example. You could make it to where it gives a percentage, and you could have more tables for bills and invoices and all that junk. But just so you guys understand the join concept, it works the same for basically any columns you use. So within here we could have first name, last name, and the amount paid. These are our columns within our table. I'm just going to open this up so we can write some. And we could say that we have individual people. We could say Caleb Curry, and then his amount paid on one of his cards is $2,200. Then we also have Caleb Curry, and the amount paid is $720. And if you wanted, you could go in and edit the join at a max amount. So that's basically, we could have a column on here such as amount owed. And we could have that in here too. And that would basically say how much they paid out of how much. So it'd look like, within here we could have amount owed, like 3,000, which is basically saying 2,200 out of 3,000. If you wanted to do that, you could do that, but for simplicity's sake, let's keep it like this. And then we could have Jimmy John, and the amount paid could be 2,800, and so forth. You could make more rows if you wanted. Now you're wondering, okay, what's an inner join? We talked about that earlier. Well, basically an inner join is going to take only the rows that either a card has a customer and a customer has a card, where they intersect. So this new table, this joined table, is going to eliminate any customers that do not have a card, and it's also going to eliminate any cards that do not have a customer. So I'm going to erase this. I'm just going to draw a little illustration to show you how this works. Now, you can find more pictures like this online, which I'll link to in the description if I can remember. Think of it like this. Here is the left table, which was the customer, and here is the card table. And this part in the middle, this is kind of like the join table, or where they intersect. So here are the customers that have a card, and here are the cards that have a customer. So within here, this is going to contain all of the rows that have a customer that also owns a card, or a card that is owned by a customer. So if you have a card with no customer, it'll stay out of the end result, and if you have a customer with no card, it'll stay out of the end result. So this is what you can think of it as. All of these things within this part of the Venn diagram or whatever, that's going to be returned. Now, there's different kinds of joins where it will only return, for example, this side or this side, but that's what we're going to be getting in future videos. So if you want to do a left join, or if you want to do a left join and go on here, or a right join and go over here, but an inner join is just the intersection of both of the tables. I don't know. I have this habit of just like wiping it off with my hands, and then my hands are like dark green. So I'm trying to be a little more civilized, you know. So how do you do this? Well, it's done within a select statement, because remember we're using data manipulation language, which is done through selects. So it would be something like this. Now, to warn you, the syntax is going to vary a lot from relational database management system from relational database management system. But the concept stays the same, so you just gotta replace a couple things, insert a couple things, boom, bada bang, you got a new join. So we're gonna say select, and then whatever comes after the select, I'm gonna scoot this over some. Everything that comes after the select is going to be the columns that we want in the joined generated table. So in the last example we had first name, and then we also had the last name, and we also had, what was it? Amount paid? I don't remember. But something like that. So that's going to be the columns we want returned. Then we are going to say, what table are we getting these columns from? So we do from, and then we say, okay, well, you may be wondering, well, there's multiple tables, so how do we know which one we're going to use? Well, we're going to put the left one first, which in our drawing we had the user, or the customer, and then we had the card. So we're going to put from customer. And then you're going to do a join, and join the other table to the customer. So we're going to say inner join, and then you're going to say the other table, which was card. Now, what you're going to do is say, how are these tables connected? So the way we had them connected, or the way we want to join these tables, is by the foreign key connecting to the primary key. And the way you signify that in the syntax would be with this little statement here. On, which is basically saying, what are we joining it by? And you're going to say customer dot customer ID. And what that dot is basically saying the first part of this is the table. The second part is the column. The reason we have to do that is because both tables have a customer ID. And then you're just going to connect that to the other table by saying equals card. dot customer ID. Now, that's basically all you have to do for this. It's going to connect, if you look at the syntax, it's going to connect. Let me get a different marker here. Colors makes things so useful, right? I'm going to use black. Okay, we got the customer joined with the card. Those are the tables. And then we're going to say what columns we want to return in the new join, and that's first name, last name, and amount paid. And then we have to say how they're related. That's the customer ID of the customer table is equal to the customer ID of the card table. And that's how you get your joined results. So the end result would of course look like this. And you're going to have first name, last name, and then amount paid. There you go. So that is how an inner join works. The next thing we're going to be talking about is left joins and right joins and all the other cool kinds of joins. Main thing though, don't worry too much about the syntax if it's overwhelming. Just worry about the concept. Understand that if you do an inner join, it's going to exclude all of the rows from either the left or the right table that aren't in both tables. It has to be in both tables in order for it to work. That's the most important thing to understand when it comes to these joins. Because if you understand that, all you got to do literally is look up, let's say you're using MySQL, just look up MySQL syntax inner join. And then you're going to get a little syntax code, replace the columns they gave you with the columns you want, and the tables with the tables that you want. It's really simple, so you don't really need to yeah, obviously you should learn this in the long run, but if you're new to this, don't worry about diving in, studying that for 20 years. Worry about the concepts, because once you get the concepts, it's easier to pick up on this junk. So, this video we'll be discussing inner joins across multiple tables. So, you're probably wondering, okay, what does that mean? Well, when we have a join, we join multiple tables. But what if we want to join that join of multiple tables with more tables? So basically, we're going to have a join over 3 or more tables. I'm trying to find my green marker, I can't find it. There it is. Okay, how does this work? Well, let's just draw some boxes just to kind of get an idea of how this might look. Okay, so you might be like, okay, cool, we figured out inner joins and how those work, but how do they work when you have 3 tables? Let's find out. Here we have 3 tables. And when we do an inner join, let's say in the last example we joined these 2 tables, we had some kind of join condition, which was something like customer.customer ID equals card.customer ID, you know? Well, it doesn't always have to be that, it just depends on what you're doing with it. But basically you're going to have a join condition right here. And you're also going to have a join condition right here if you want to join in another table. These tables don't necessarily have to be connected, like a many-to-many relationship. Because when we designed many-to-many relationships, it looked like this with like the intermediary table. It's not always the case. For example, this table could have a relationship with this table, and this table could have a relationship with this table. But this table doesn't necessarily have to have a relationship with this table. Think of it like this. When you do the join on these 2 tables, you're going to get a result set, right? Then if you want to know what your next results are going to be when you add this table in, think of joining these, and you're going to get a final result set. So if you do an inner join across multiple tables, the end result set is going to be smaller than this. Because you think about it, if you join these 2 tables, you get a result set. But now, you have to take all of these rows, and you're only going to display the ones that meet the requirements of this join condition, which is going to decrease the size or the amount of rows in this table, and it's going to be shorter. Most cases. Now, let's talk about this a little more. Let's go through the example we had before. with the cards and the customer, but we're going to add a new table, right? So we're just going to draw this out a little bit. This is the customer table, and we had a customer ID, a first name, last name. You can also have any other junk you want to store about the customer in there. Then we had the card table. We had the card ID, and then the customer ID, and then the max amount or whatever else you want to store about the card, or the bill, or whatever, the price, or the interest rate. Now, let's throw in another table in this equation. Let's throw another table into this equation. It's going to be a card type table. So you know when you get like a credit card, because all you college students are like, yeah, I need pizza. Well, that card has a type, such as Visa, MasterCard, or whatever else, American Express. Well, that's kind of like the card type. Generally, a bank would just give out like one card type, but we could say that they can, we could just say what kind of card type the card in this table is. Now, when you structure it that way, how many different card types are there? 4 or 5 main ones: Visa, MasterCard, American Express, maybe 2 other ones that are somewhat popular. There's not that many. So if you were to store that in a column in this one, you're going to get a lot of repeating data. And then, for example, if MasterCard decides to change their name or they get bought out by somebody else, and all the cards now are named UltraCard, then that's going to cause problems, because all of the you're gonna have a MasterCard and then UltraCard. It's gonna be confusing. So what you can do is use a lookup table, which we discussed in a long video ago, and that's just going to be basically a reference to another table with all the possible options. And that way, if you needed to add a new option, you can do that easily and then just reference that. Or if you need to update an option, or if you want to put extra information about that option. For example, if MasterCard has a standard fee or something, you could put that within the card type table rather than within the card table. Because if you have the card table, like look, if you have card ID, and then you have card type, and then you have something about that card type, so card type interest or something, well, this is a transitive dependency, which is a violation of the normal forms. I believe second normal form. Did I forget? Third normal form. I'm sorry. Anyways, that's not good, so you'd want to take these and put them in a new table. So a lookup table is a defense against problems like that. And it also reduces integrity problems, and it can also reduce repeating values. So now let's design this. We're going to have a lookup table, which is card type. And this is going to have card type ID, and then the card type, which is going to be like the name of it. And then you could have any other rows about the card type in there. And then in the card, we're going to reference that with a foreign key. So it's just looking it up the values through the lookup table. So we're going to have card type ID. That is a foreign key. Now let's draw these connections. Customer ID is a foreign key to the customer, and the card type ID is a foreign key to the card type. So you can see we have all this information spread out over 3 tables, and we want to join these and create a new generated table that contains information from all 3. We want it to be an inner join in this case, but you can do the same thing with outer joins and other types of joins. We'll be discussing this soon. But for this, we want it to look like this. This is what we want our generated view or our new table to look like. We want to select stuff about the customer. Just going to add some columns in there just to put them in here. We could have the first name, last name, email, phone, amount paid, and then we could also have the card type right here. Need some more room here. guys want to know something cool while we're completely off topic, just for a second? I always like drew comics as a kid, and I always like drew a bubble around like either a thought or a talk, and then I try to fit all the words into that, and it never worked. And then my master drawing friend was like, dude, draw the words first and then draw the bubble around it. It was like the best idea ever, but I still don't do it. I mean, I always have to erase the sides of my database tables to fit more junk in there. I should always write the words first and then draw a square around them, but this will work. These are all from this table. This is from this table. The card type is from this table. It's a join across 3 tables, and you could of course add more. Now, the join conditions, well, it would be, for this, the customer ID is the same as the customer ID, and the card type ID is the same as the card type ID. So this table first is going to exclude, here I'll just write out what it's going to exclude. This isn't part of the table, but I'm just putting it here. It's going to exclude customers with no card, cards with no customers. That's going to be the first join condition, because we're going from here. And then the second join condition, it's going to remove cards with no card type, and also card types with no cards. And that means basically if you have MasterCard as a card type, and you haven't created any card rows that also have the foreign key that references MasterCard or whatever I said, then that's not going to be included, because there would be nothing to put with it. And just say MasterCard, no, 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 no. That's because no cards have it, and no people have cards that have it. So that's what inner join is going to do. It's going to do all of this. So the end result is going to basically get smaller and smaller and smaller for every single table you add. Now, there's a couple other things to think about here. It has to do with things being null or not null. Okay, let's talk about it. The way we have it set up is the customers, they can have a card, but they don't have to have a card. That's because there's no required column in here that says you have to have a card ID. So you could have a customer that has multiple cards, for example. We also have a card table, and the way we have it set up, the card doesn't necessarily have to have a customer. If you want to change that, you could take this customer ID right here, and you could make it not null. That is going to change the end result, because now every single card is going to have a customer. That means cards with no customers, although functionally it's removing all the cards with no customers, every single card has a customer, so the end result doesn't eliminate cards with no customers. Functionally it does though, because that's what the inner join does, but since there's none to remove, it doesn't do anything. So you can kind of think of it as not doing this, even though functionally it does. Remember that. It's a difference. Alright. Now, we also have it where the card, I would say it should have a card ID, or a card type ID I should say, because almost every card you're going to get ever is going to have a card type, right? Unless for some reason they wouldn't, you'd likely have that as not null. So functionally this is going to remove cards without card types, but since it's labeled as not null, every single card is going to have a card type. Therefore, in the end result, it doesn't really remove cards with no card type, because every card has a card type, so there's nothing to remove. Now, card type, there might be a possibility you're offering a new card type, such as, let's say, so I can't think of any cool names, like legit card type 12, and like a new company comes out and you get a legit card type 12 card, and all through your new bank account, and that might, when you first get that, there might not be a card that has been issued that card type yet. So in the end result, you're only really removing the customers with no cards, and I guess the card types with no cards, I'm going to keep that, so that's going to stay. So these two are going to be removed, and this is the end result here. We're going to keep card types with no cards and customers with no cards. That was a big one. Man, my throat hurts. We talked about it in the last video, but never actually talked about the join conditions very much. So I'm going to go over a new example in this video. Let's do this. So, we're going to have a user table, not a customer table. User table, and then we're going to have a comment table and a video table. So think of like a video sharing website, like, what's that one called? Starts with a U. I don't know. But anyways, we have a table here. We also have a table here. We also have a table right there. Alright. And these are all connected, right? Boom, boom, boom. And I'm just going to write the name of the table. I'm not going to really write any comments in here just because it's low on space. So we got the user, we got the comment, and then we got the video. So the only way the user has any connection with the video is through the comment table, because a user posts a comment on a video. Does that make sense? Hopefully it does. I don't even know why I ask you that still. I'm trying to stop. It's driving me crazy. What are the join conditions for this? If we want to do an inner join, let's discuss the conditions and also the results we should expect. Okay, so let's just define the keys that are going to connect these tables. So we have a user ID, and then we're going to have a comment ID, and then a user ID, and then a video ID, and then this video ID will be referenced in this table by a video ID. Okay, now if you think of this as a many-to-many relationship between the user and the video, you could potentially get rid of the comment ID and just use the combination of user ID and video ID. But that is not the best way to do it. One user could post multiple comments on one video. So, you see, like, if we had this comment table, we could have user ID, and then we could have video ID, and then we could have comment. And we could have the user ID was 7, video ID was 106, and the comment was lame, and then the user ID of 7, video ID of 106 could be JK. So, this is a bad idea. You wouldn't want to use those combined. Unless you're working on some kind of thing where you can only leave like one review on a product, to say instead of just user review product or user review whatever. In that case, you could use user ID combined with the product ID or the video ID to allow that. But I'm going to use the comment ID in this, and this is going to be a surrogate ID that's going to be used as the primary key. And these are only going to be foreign keys. The user ID and the video ID, they're only going to be foreign keys, and they're not going to be part of a compound's a compound key in any sort of way. They're just another column that's a foreign key referencing a table. Just so you guys understand the structure of how I set this up. Alright, now there's going to be a join condition right here, which basically a join condition is what columns are in both tables, right? You don't always have to say user ID equals user ID, or customer ID equals customer ID, or comment equals comment ID. You can do other stuff with like greater than, less than, and all those fancy things, but we're just going to be using equals because it's the most common one and it's the easiest to understand. The one here is going to be the user ID, so we're going to have user.user ID, and it's equal to comment.user ID. This is the first join condition. Now for this, we're going to have a second join condition between these two. And the only thing we can use is the video ID because it's the only thing in both tables. So we're basically going to have a comment.video ID equals video.video ID. We got to say what table they're in because they're in multiple tables. So we have to use the dot syntax. Table dot column equal to table dot column. I know you guys probably can't even read that. I wrote it so small, but it's okay. As long as you understand, this is the join condition for these two, and this is the join condition for these two. When you join these, you're going to join them by those columns. And now what about not null and null columns? What are they going to be returned as? Well, the way we have it structured, a user can comment on as many videos as they want, so they can be in the comment table multiple times. So we got one to many there. Now, a comment can only be posted by one user and can only be posted on one video, because each individual comment is going to be a separate row in the comment table. So for video ID, we're going to have that set to not null. And also for user ID, we're going to have that set to not null. That's because there should never be a comment that doesn't exist on a video, and there should never be a comment on a video that wasn't posted by a user, right? Now for video, we don't necessarily have to have comments on it, so there's nothing we need to worry about that. Just like a user, we don't have to worry about having to have a comment. So the only time we need to put not null is on these two columns to make sure the comments exist with everything they need. You see, the user ID would be not null because every user is a user and every video is a video, but we don't have to say every user has to comment. That would make it impractical. So that's the setup for the not null and the relationship types. So then when we do an inner join, in this case, what are we going to get? Well, I just want to think about that for a little so we can kind of understand what our end result is going to be. So what do we want? Well, we want a table that looks like, now let me move this up a little bit. We want a table that looks like this. And that's because we wouldn't want it any other shape, right? I'm just teasing. But basically, we're going to take the user with the user ID, and likely we'll have more information about them, such as their username. So if you wanted, you could also include that in the table, which would likely be done from the beginning, because you likely do your joins and stuff after that. So make sure you put your username in there. You don't have to add that in there, because then half your users won't have a username and half of them will, which isn't good. So username from the beginning. You'll likely include your username, and then we'll likely include the comment. So we would need to include the actual comment in the comment table. The reason I didn't put these in there earlier, because I just wanted to think about the keys for now, but now we can put those in there, so that, since we're designing this, right? And then we also want the video title, and maybe a link. But we'll just go with the title for now. So these are the three columns that we want to include, and we could have set it up in a table, and each individual row is going to be a new comment. Well, let's think about what can be excluded from this, so then we can decide which ones actually will be excluded. Well, let's just ask questions. Can a user be excluded? Well, if we're using an inner join, we're only going to return users that posted a comment on a video. So yes, any user that did not post a comment will not be included. Now what about videos? Will videos be excluded? Well, since it's an inner join, we're not going to include any videos that do not have a comment from a user. So yes, videos can be excluded. They likely will. So videos, we're just going to put X by to say that it can be excluded. Users can be excluded. Now, can comments be excluded? Well, let's think about each individual key. We have the foreign keys, user ID, which is labeled as not null. So that means every single comment is going to have a user, and also the video ID is not null, so every single comment is going to have a video. So in this situation, all of the comments will be returned, so we can't remove those. So within here, every single comment is going to be included. So if we had 10 comments, we're going to have them labeled 1 through 10. We actually want to label them, but we would have all 10 of them there. And then only some users would show up here. And all of their comments, all the comments would show up in this column. So it would be like, It'd be like, and lame. And then the video title, only some videos are going to be included here. Pizza. Subscribe. That's how that's going to work, and let's just see how that goes. So, yeah. Let's see this in action. Here I have some snapshots of some tables I created, and I'll just be illustrating this, and I'll be drawing on the screen as needed. And I have one of them Wacom tablets, and if I am drawing all over the place, it's because I haven't installed the software, not because I can't write better than a kindergartner. Alright, so let's begin. Here we have what would be like a user table or something. We got the user ID, email, username, and the pass, which is like just encrypted basically. And this is going to be joined with the comment table over here. I mean, sorry, that's the video table. Here, this is the comment table. Alright, so here we got each comment and foreign keys to the user ID and the video ID, as well as the actual comment. And then we have the video table. The video table has the title of the video and also the description, which would go like under the video or on the side or appended to the title, whatever you want to do for your website. And this is just what the video is about, right? And as you can see, I'm advertising my database design course, which is pretty awesome, right? And what we want to do is we just want to join these, so we have the username, the title, and the comment, all from 3 different tables. So the username comes from the user table right here, and then the title comes from the video title right here, and then finally the comment comes from the comment table right here. So let's go back to the joined table. What we want to do is if we're using, let's say, the comment table, we want to replace the user ID with the username and the video ID with the title. So let's look at the comment table. We want to replace all these numbers in the user ID column with the username, which means we have to reference the user table. And then the video ID we want to replace with the video name, which means we'll have to reference the video table. And then the comment ID, that's just the primary key for this table. Alright, so let's just kind of look at how this works. So yeah, this is how it works. The username from the user table, the title from the video table, and the comment from the comment table. Now let's go through how the join looks. I have all the tables here now. It's kind of small, so sorry if you can't see well. But we have the join table right here. This is the joined table. That's the join. Then we have the comment, the user, and we have the video. And we're going to basically just borrow some columns. So the title, that's going to come from the video. So I'm just going to go over here. It's going to come from over here. And then the username is going to come from up here. And then finally we have the comment. And the comment is going to come from right over here. If you can even see that, probably not. Okay, so there's a couple things though. Not all of the columns values are included, so not every single row. That's because this is an inner join. Now, if you look at the username, we got All Sky Pizza. Let's follow this user. So let's go to the user table. We got All Sky Pizza right there. Then we got, if we keep going down this table, we got Ha 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 12, which of course is using my mouse now, right there. Then we got Pablo is all which is Pablo is awesome. Then we got Milk and Coo, which is milk and cookies. And then we got Yellow Swag Ha, which is yellow swag hashtag. YOLO swag, sorry. And then we got but I don't even know what that says. Which is this person right here. Best speller in the world. Okay, I made these a while ago, so so you can see these two people though, they're not included. That's because it's an inner join and they are not part of the end result. Now let's look at the videos. So we got the videos, we got database assigned 1, 2, 3, 4, 5, 6, 7. Where's 8 though? I don't see an 8 on here. Well, you can see 8 on the video side right here. It's not included. So 8 is not included. Basically, we're taking different columns from different tables, but not every single row is included. That's because they don't meet the qualifications for the inner join. So the syntax for something like this would be like this. So you have the select and then the username, title, and the comment. These are all from different 3 tables, but it might vary on how it looks for your database management system, but it'll look something like this. And then from the user, comment, and video table, and we just do the inner join the comment by the user ID and the comment user ID, and then the inner join of video by the video ID being the same as the comment video ID. So what's the difference between an inner join and an outer join? That's what we will be discussing in this entire video. It's going to be about 20 videos, so hold it. No, I'm just kidding. It won't take too long. Once you understand what an inner join is, picking up outer joins and the other junk is like super easy. Okay? Kind of how like once you learn one programming language, the second one is only somewhat less hard, right? You can see I have some junk written behind me. Let's look at it. Alright, so we have what's known as a join condition. That is at the end of the join statement. Do you remember doing this? I can't hear you. I'm just kidding. Okay, so we got the customer.customer ID and card.customer ID. That means there's 2 tables, the customer table and the card table. And then both of these have a column customer ID. It's basically just simple dot syntax, the table dot column. And this is making an association. So this is saying that we want to join 2 tables and the rows that need to be connected are connected by the column of customer ID and customer ID. So the 2 columns here, this is going to make a connection, and our join is going to be built upon that, so we know where to connect things. So the way this would work with an inner join, let me just show ya. Let me just redraw those 2 tables real quick. We have the customer, and then we have the card. So this is like a bank, and people can get credit cards, and a person doesn't necessarily have to have a credit card because they can go to that bank without having a credit card. And also, a card doesn't necessarily have to have a current owner, because it could be a disabled card, or it could be a card that hasn't yet been activated, or something else could happen to where a person doesn't own that card. So, there's no required columns for this. Now when we join these, the join table is going to only include customers who own a card. That's going to be the end result. That is with a inner join. So we have the customer, card, join table of card and the customer that is exclusive, pushing away all of the customers with no cards and all of the cards without an associated customer who owns that card. The outer join works a little differently in that it's still going to return all of the rows from one of these tables. You can decide which one, whether or not they have an associated entity on the other side. So that join statement comes in here, it's important. So we had it to where it was the customer ID. I'm just going to put C for short. If we have it where we have what's known as a left join. I'm just going to write it over here. It's going to basically ignore that statement, and it's going to return all of the rows from the left table. The right one, though, is still going to be obeying that join statement. So the join statement, let me write it out, was a customer. So with this left join, all of the rows are going to ignore this on the left side. So it's going to return back every single row. On the right side, though, it's going to only return the ones that have a customer ID that has a customer ID of the same value within the customer table. So, for example, we could have a card with the ID, the customer ID of 7. So that's customer ID, not card ID. So that's referring to the person who actually owns the card. Alright? We could have that person over here. And since if you basically insert this into the join condition, we have 7 equals 7. Because this card customer ID has an equal value in this table, which means this card is owned by that person. It's kind of how it works. But with an outer join, we are going to ignore that and basically say we're going to return all of the rows for either the left or right side. So there are three main classifications of joins, outer joins that are. I'm going to write them all, and then in the next videos we are going to discuss them. There's a left outer join, right outer join, and an... did I seriously write outer join? Ugh, I am so dumb. I meant to write full outer join, excuse me. Oh man. But basically, we're going to be discussing these two right offhand, and full, that can be a little more complicated for some database management systems. So we're going to probably discuss that a little farther down the road, hopefully. Now, the right outer joins work basically the same way as the left outer joins, but instead of the left table, it's going to be the right table that keeps all of the rows. Now, if you don't know what I'm talking about, please watch the last video or two. That's going to solidify your knowledge, and you'll be like ready to tackle this. Because I'm not trying to get you to watch my other videos, I'm trying to teach you something that's a requirement to understand this, and I don't want to have to reteach it all for the sake of one little concept. So let's draw this out a little bit. We have it to where we have two tables, a customer table, and a card table. So this would be like for a bank or something. And let's first see what a left join would do. A left join would take all of these customers, and then it'll take only the cards that have an associated customer and return those. So we'd basically connect the dots. And then we would get a join view, which is going to list all of the customers, but only the cards that have a customer. So it's just going to be like customer, list a card they have. And if they have another card, it's going to list that customer again, list the card they have. And we discussed that in depth in the last video. Well, for a right join, it's going to work the same way, except now it's going to do it for the other table. So we're going to have the same exact setup. We're going to have a customer and card table. And a card table. Now, if we set it up with a right outer join, it's going to take all of the cards, put them in the join table. So we'll have every single card, and then it will list the associated owner of that card. So, card, and then the customer. Now, there's something to consider with this. If we set it to where within the card table we have customer ID, we give that a column characteristic of not null, that might confuse you a little bit, because then every single card here is going to have an associated customer, which kind of that's the whole point of the right outer join, or the left outer join for that sake, is to include the rows that don't have that association. So if it's set to not null, it's going to return them all anyways, whether you use the right outer join and so forth. You guys understand? Because basically, if we use the right outer join for this, it's going to return them all, but it's going to return them all anyways because every single one has an associated card. We'll discuss that more in the future, don't worry about it. Now there's something else to consider. This basically works the same exact way as the left outer join, except it's switched around. So, when we discussed in the last video how you could say which table was the left, right, where the from, so you have basically the form would be like select, maybe, and then you'd have like the columns first name, last name, and a card amount, or you could have, yeah, card amount, that's good. And then you have something that says like from. Well, the column that you put right here, or the table you put right there, is considered left when we're talking about this design stuff. So, in theory, you could switch it around to where a left join works the same way as a right join. You're just switching the direction of the tables. So, in practice, most people don't even use right joins. I'm only teaching you so you understand when you see one. Instead of using a right join, they'll often use a left join, and then they'll just flip the column, the tables, I'm sorry. So like this. You have your two tables, and I'll give you two possibilities that are going to give the same result. You could have your customer, and then the card, and you can use a right outer join, or you could have it to where you have, over here, you have the card and the customer with the same exact columns and same exact foreign keys. Nothing changed except in design, you just switched the things, and when you make the SQL statement, you're going to switch the location of the tables within that statement, but overall the function works exactly the same. And now you're going to use a left outer join. These are going to return the same exact thing. Because if you do this one, it's going to return all of these rows and the associated columns with those rows. If you do this, it's going to return all of those rows and all the associated columns with those rows. So either way, you're getting all the cards in part of the customers. See? So in practice, a lot of people only use left outer joins for consistency and clarity, so if someone else sees it, they already know it's a left outer join. They don't have to worry about left or right and then draw it out and get all confused. Most people just use left outer joins, but you can always use right outer joins if you really wish. That is up to you. Well, I've been talking a little bit about not null columns, basically columns that aren't allowed to have no value. And that can cause some confusion when it comes to joins because you might get results you don't expect. And I'm just going to be explaining that just a tiny bit more. This video will be quick, so if you already understand it, go right ahead and skip it if that's what you wish. Alright, so I'm going to be going over an example of a user comment system. So basically you're going to have a table with the users, and then you're going to have something such as a comment table. And you might have a table such as video or blog or whatever you're commenting on, but that's out of the illustration for now, don't worry about that. Well, in this example, we have some columns that are labeled not null. And what this means is that you're not allowed to have them to where there's no value in that row for that column. So for example, if in comment we had comment ID and then we had user ID and we gave it a column characteristic of not null, well, what is that going to do? That's going to basically say that every single row within this comment table has to have a user ID associated with that comment. And that would be the person who posted that comment. Now, the user, on the other hand, doesn't have to post a comment. It's a one-to-many relationship, and the user does not have to post a comment, but a comment has to be owned by a user. That's important to know. So there's three real possible options of joins that we could do on this table. The first is an inner join. I'm going to put these in caps because it's probably just better to do that. Now the inner join does not matter which one is left or right because it's going to take the middle of both of them. So the positioning of your tables within your query of the select statement does not really matter. All that matters is that you're using the inner join. What is the inner join going to give you? And the inner join will give you all of the users who have comments. That's because if a user doesn't have a comment, it's not going to be in, his ID won't be in the comment table and he'll be left out. If there's a comment that doesn't have a user, well then it would be left out too, but that's not the case because it's not null. Right? The other option is a left outer join. And I'm going to go into places in a second. Left outer join, and then we could put the comment on the left. So if you need help thinking about that in your head, switch these two tables around. But I'm not going to do that because that's part of the illustration already. We're good. All right. The other option, well actually let's talk about what that's going to do first. Left outer join is going to give you all of the comments and then give you the associated users who have posted those comments. So every single comment will be included. So the return result will be all comments and associated users. Okay, now think about this though. These things are actually going to give you the same exact thing. That's because if you do an inner join, it's going to give you all the users who have comments. Okay? So it's going to take you all of the users who have a comment, put it in there, and then it's going to take all the comments that have a user and put it in there. You hear that? All the comments that have a user, all the comments that have a user. So these are going to give you the same result. So just understand that. The third option is to flip the left join, the tables that is. So we got a left outer join with the user table on left. Okay, now what is this going to do? It's going to give you all of the users and the associated comments from those users. Now, let's talk about, so we're going to have, it either includes them all or excludes some of them. So basically, if it includes all of the users, I'm going to label it with a star. If it only includes some users, I'm going to label it with an X. Same for the comments. All the comments is going to be a star. Some of the comments is going to be an X. So, users who have comments. Well, only some users are going to post comments, so that's going to be X on the user end. But all of the users who have comments, that's going to include all of the comments because all of the comments are labeled as not null. So every user posted a comment has a row within the comment table. So it's going to return them all. So it's going to return them all on the user end. That's a star. Now left outer join with the comments on left returns all comments and associated users. All the comments, so all the on the comment side, it's going to return them all, but the users, not all of them, just part of them. Now left outer join is going to return all users and associated comments. So the first one is some users, all comments. The second one is some users, all comments. The third one is all users and all comments. That's what you kind of need to do when you're trying to plan out which join you need to use. Go through all the possibilities with that join and just write them out. So you see that these two are actually the same. This one is just a tiny bit different in that it includes all of the users. So you may be wondering, well, which of these two should you use? Well, to be honest, it doesn't really matter. If you wanted to return all of the comments, don't worry about whether it's not null or not. Just use a left outer join with the comments on the left, and then you're guaranteed to have that. You don't have to worry about whether it's not null or not. So that's what I would do. If you only want the users and the comments included, and you don't want to include any comments that don't have a user, which is never going to happen, then you do a inner join. So what you do is you just think and pretend all the columns are nullable, or they don't have to have a value, and then you plan your joins around that, and it can still work the same way if that's what you'd like to do. Otherwise, you can just plan it out like this and realize you can use either one of these and it's going to work out fine for what you want to do. In this video we will be discussing using outer joins when there are 3 or more tables. We will be discussing the example using 3 tables, but you can basically apply it to any example as long as you understand the concepts. I really recommend that you watch the video about using inner joins when there are 3 or more tables, because the concepts are going to be basically the same except different results will be returned. So for this, the best way to think about it is, let's say we have 3 tables. Ignore these 2 right now. We have a user, comment, and video table. So basically, it's a system where you can comment on videos. Each video that does get a comment will be in this table, and every user that posts a comment will also be in this table connected with that video, right? What I'm going to do is I'm going to use a left outer join on this side and a right outer join on this side. And we will just see what those results are like. Alright, so first thing is first, let's join the user and comment table. That's the best way to think about it, is to imagine these 2 tables being joined here to make a new temporary joined table, and then imagine this new temporary table being joined with the 3rd table to give a final result joined table. So if we do a left outer join here, every single user is going to be brought down to this table. In the situation of a left outer join, it will only take the comments that have users, because there has to be an association of the user ID in both tables for that. But it's likely that every comment is going to have an associated user, because that user ID column will likely be set to not null. That way you don't have comments that aren't posted by anybody, because that would be weird. So this will also return all comments. Great, now that we have that new table, you see we basically just took everything from up here. Let's imagine taking this and joining it with the videos. And we're going to use a right outer join. So this is going to be right outer join. For a right outer join, we are going to take all of the videos and bring them down here. That's basically how right outer joins work. They will automatically take every single row from the right table. And then we're going to take any row in this table that has an association with the video table. So that means the comments will have to have a video, which all of them will. Alright, so what will be removed here? Well, some of the users will be removed. The reason that is because some of the users aren't going to be in the comment table. And if they're not in the comment table, they can't have an association with the video table. So think about the join statements here. We'll likely have something where it's like user ID over here is equal to the user ID over here, and then we'll have it to where it's then we'll have it to where it's a video ID over here, and that's equal to a video ID over here. So when we grab all of these, we have all the users and all the comments, because all the users will have a user ID, and we don't have to have those users in the comment table because it's a left outer join, which automatically takes all of the users. All of the comments will be returned because every comment will have an associated user. But once we get over here, it gets a little different. Now it's about the video, not the user. So we're going to take all of the comments that have a video ID and all of the videos that have a video ID. Because it's a right outer join, we're going to take all the videos, whether or not they have a video ID, in the comment table. So the first thing, take all the videos. We're also going to take all of the comments, but we're only going to take some users. The reason that is because if a user, let's give some example data. Let's say we have a user over here with the ID of 7, and he he doesn't leave a comment, but because we do a left outer join, he comes down here anyway, so now he's in this new generated table. Well, he has a user ID, but does he have a video ID in the comment table to be associated with the video ID in the video table? No, he does not, so he wouldn't make it on past this stage, and he wouldn't be in this final outer table, or this joined table. So the final result is going to be all videos, all comments, and some users. That's just an example of using right and left outer joins when there's 3 tables. You could do the same thing with inner joins. So if you did an inner join, it's only going to take the users who have comments. So, I mean, you can basically apply the same example to a lot of different situations to get the results you want. As long as you understand how a left join works, how a right join works, and how an inner join works, you can get essentially everything you really need to get. The only one we haven't really discussed is the full outer join, which you might need sometimes, and that's a little different, so we'll be talking about that soon. This video will be taking a quick break from joins that we've been discussing for the last 8 or so videos, and we will be discussing something that's a little unrelated, but kind of related, if that makes sense. But anyways, we will be discussing aliases. So an alias is when you rename something and you give it kind of like a nickname or more of a user-friendly name, or a name that you are more used to seeing. And you can do this when you're writing select statements in SQL, and you can do that to either make it easier to write or easier to read. So when you want to give a table an alias, you will use the as or as keyword, and that's going to say anything that follows is what we want to call the table. So let's say we had that user table, and instead of using user, you wanted to say customer. Well then, when you use the table in the rest of the query and you use your joins, rather than using user, you can use customer. And often you won't take a short name and make it into something longer. You will do something like replace user with a U, and then instead of you doing user dot user ID, you would be u dot user ID. That's an example of an alias. When you do it on tables, it's often to make the select statement easier, but you can also do it for columns. Now, when you do it on a column, it's going to work a little differently. So in a select statement, you put all your columns at the top. So here's just an example of what you might say to a database. You're going to select the email, first name, and last name. When you use an alias with columns, not only do you change what the column is called, but it's going to change what it's presented as. So when you get that new structured view, that generated table, and it looks something like this, rather than saying email, first name, or last name, you can make it say email FN, FN, LN for first name, last name. Or you can take out that underscore and you can replace it with, first space name. This works similar in the way that the other alias works for the tables, except you put it right after the column. So you could say select email as contact, comma, first name as, and then you put in quotes. You gotta quote it. That's because you're telling it this is what you want it to be. You want to put it in quotes so that way it's understood to be a string. You can see here I put that space there, and without the quotes that can just cause a problem. Comma, and then underscore last name. You guys see all that? That's basically how an alias works. You can take the alias to make things easier to write, easier to present, and also it can change the way the view looks so it looks more pretty, right? In the next video we're going to be talking about joins that you reference the same table, or a self-join. And basically you're going to take the table you have and basically tell MySQL you want to make a copy of it essentially and join these two tables which are the same. And the only way that's going to work is if you give it an alias. So this table will be called T1 and this one be T2, for example. So that's an example of when you would use an alias. other than renaming your columns or your tables. The way a self-join works is you take a table and you are essentially joining it with itself. And that's what kind of makes self-joins confusing, and a lot of people can't find practical purposes for them. I'm going to be giving you... I dropped my marker. I just got white marker. Oh. Self-joins are complicated, and a lot of people can't find practical purposes for them. In this video, I'll be giving you at least one good reason for them, so hopefully this video is helpful. So when you have a self-join, think of basically duplicating the table you have and making an exact copy, and then joining those two tables together. That's a good way you can think about it. So for this example, I'm going to be using a user account system on a website. And you know how some websites have like a referral option? Basically, if you refer somebody, you get like 20% of their money or their points, or 10% of their money, so forth. That's like referral marketing. And when you do that, you are assigned a person who referred you. Right? And it can become a chain, like this person referred this person, referred this person, referred this person. So within a user table, you might have a user ID, and then on top of that, you're going to have, email, first name, last name, and the person who referred you. I am putting the person who referred you within a column known as referred by, and this is actually a foreign key to the same table. So within here, you're going to have numbers such as 12, which is going to point back to the user ID of 12. So for example, the user ID 11 might be a person who was referred by the user with the user ID of 12. Now the only way that you can make this really work for a join is if you use a self-join. Basically what we want to do is we want to replace referred by with the ID. We want to use a join to replace this number with that user's email, which I also forgot to put in here, so, just throw an email in there. So we'll take this, and then our outputted result will look something like this. And this is the table that we're going to have, and then we're going to insert data into that table. So we might have a user such as Caleb Curry, and his email is going to be swag@yolo.com. And then it's referred by that we're going to replace that number with a user's email, such as hot sauce at yahoo.org. So that's just an example of what we can do with this self-join. Now in order for this to work, we have to tell the database that we're going to be using the same table in basically two different tables, and that can kind of be confusing, and in order for that to work, you have to use what's known as an alias. I talked about those in the last video, so be sure to check those on out. So to begin, we just kind of think of a name of what we could call each table. We could have the first table, which would also be the user table, and then the second table, which would be another copy of the user table. Now we're not actually copying the data. This is just for illustration point. It's going to use that same table to withdraw the data from. And we could say this one is V1 and V2, for example. Those are our aliases. And in order to define those, we put as after our data, after our table, and put V1. So we could say user as V1 and then join user as V2. This is something kind of like what you would do. So now we have a user as V1, and then we're joining user as V2. And it kind of gets the idea that, oh, this person wants to use the same table for this situation. Let's try to figure this out. Let's begin. We are going to put this within a select statement. And I'm going to give you some specific syntax just so this can kind of make sense. So we have a select statement. Then right after the select statement, we always put the columns we want to take our data from. Now, this can get kind of confusing though, because we have two different tables that we're going to be taking data from. So we have to think which table we want to take which columns from. The way we had it set up before is we have this table and this table. This was V1 and this was V2. Well, let's kind of, in our imaginary brains, which we don't have, we're going to say this table is for the user and this table is for the referrals. So we're going to take from this table, we'll take the user ID maybe, or the first name, the last name, and the email. And then from this table, we are going to take the email of the person who referred you. So we'll take the referred by person's email. So the way this will work is we're going to have the user ID such as 7 and Caleb Curry, and then their email, and then it'll have an ID of 7 or 8 for the referred by, and then that's going to go to the second table to get that person's email. You got to keep this in mind, and you have to figure out what you're going to name your tables before you start to select, because now that we are going to say the columns, we have to qualify those columns by putting a dot before them and saying what table they're from. And we can just use the alias name that we've had or made up. So we could say select V1 period or dot, and we could say first name, comma, and then we could say V1 dot last name, comma, V1 dot email, comma. Finally, we're going to take V2 and we're going to take that person's email, or you can do their first name or last name, whatever you want to put in that referred by thing. If you wanted to say their first name, you can say V2 dot first name. If you want it to be their last name, it can be V2 dot last name. Or if you want a combination of both, you can use a concatenation function or something. So we're just going to use the email. So we're going to take the V2 dot email. Now that we know what columns and what tables that we want to take the data from, we actually have to put the from statement still and say something like from, and then put the table we are taking this data from. This is where we are going to define our alias. So we could say from user as V1. That is going to basically tell the database that the user table is known as V1. Now we can do a join. Join, this is going to default to an inner join if you just use join like that. We could say join user as V2. That is going to basically tell them that user is also going to be known as V2, but it's going to be considered a different table in this situation. Then you're going to do the on, which is going to say where we are going to join these things. Now this is where it can get really confusing because there's so many possibilities that you can put right here. For this situation, we are going to take V1 and we're going to take the referred by column, and that is going to be the same as V2 user ID column. So if you can think about this, imagine literally two tables with the same exact data. Here's V1, here's V2. And we have a user ID, and then within here we also have a referred to by, or referred by, I guess. That's going to reference the user ID of the V2 table. So that means we need to basically make this connection and say that if there is a 6 over here in the referred by table, it needs to be the same as the user ID over here that has 6. If you need more practical data to understand this, imagine we have this guy over here, and his name's Samuel, and we have this guy over here, and his name is, yeah, that's his name, and refer Samuel. That means is going to have the user ID of 6 within this user row of the user ID of, let's say, 12. So Samuel has the ID of 12, and he was referred by the person with the user ID of 6, which is and then this other table, which is also the same user table, it's going to refer to the person with the ID of 6, which is this guy. Hopefully that makes sense. But in reality, you're not going to have two exact copies of the data. It's smart enough to understand that these are all one table, so it's basically going to take that referred by and then go back to the user column and join that into what would look like taking two tables and putting them together. That's why it can get kind of confusing. But when you take this query as it is and you put it in your database, you will get something that looks like a normal joined table It'll be one really big table, and it will have the columns that we selected. v1.fn. On top of this, we're also going to have the v1 last name and the v1 email and the v2 email. Then if we were to put example data into this, it would look something like Caleb Curry, an email, and then the v2 email would be like another guy's email, so such as swah@swah.com. That's what it would look like, and it would just give you all of the rows for that. So yeah, you can mess around, do all kinds of cool joins and all kinds of stuff. But there's one more thing that I want to tell you, and that has to do with aliases. Well, you know, this might not be too pretty how you have it right now, and it might be confusing having an email and then right beside it another email. Like, what do those mean? Well, you might want to say that one column is the user and another is the person who referred them. So you can use an alias for that too. So for that, you also use as, but instead of putting it in the from, you're just going to put it right after the column that you want to change. So you can put it here, 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 and here. So if I wanted the table 2 email, or the person who referred, you could make it say like v2.email as referred by. And this you're going to want to put in quotes to say you want that string as the title for that column. And then when you get that new table, that join, instead of saying email, it's going to say referred by, and then it'll list the data. Yo, what's up my homies? This video, or this section of the video I guess, we'll just be discussing this in a little more depth by showing this real example that I explained on the board. So you can see I have a user table, and within my user table, you know, I got user ID, pass, email, first name, last name, and a referred by. And this referred by is a foreign key referencing the user ID. It's kind of interesting how that works. So you can see here, it was this guy, llamaswag@yolo.com, was referred by to, which in this case would be himom@lololol.com, which he basically referred everybody. That's why he has a 0 here. And if you scroll down, we also have some people who are referred by 1. Basically, what we want to do is we want to replace this referred by with the person's email. And to do that, we can use a self-join. And who knows, there might be a way easier way to do this. So if there is, just be sure to let me know. Alright, so here's a query that would work to do that. So let me just refresh this. And here's what it's going to do. It's going to select the first name, last name, email of the person who was referred. And it's also going to take the email of the referral person, the person who referred the other person. It's a person within this referred by column. Okay, so you can see here we got the first name, last name, email. That's one thing, and then the referred by email. So how does this work? We can take the columns, and we also replaced the email of the referred by and put referred by. That's why it shows up right here, which is what we want. That's good. Then we say what table? We're going to take the user table and call it v1, which you can basically name it whatever, as long as you update right here, then it'll still work. That's just a name I made up. I couldn't think of something cool, but basically version 1, you know. This inner join is we're taking our other version of the table, and just so you know, this inner is optional, so you can take that away and it's going to work exactly the same way. Then we're going to say how it's related. So basically, this referred by email, that needs to have an ID in that table that refers to a person. So the referred by is going to have an ID, and that needs to match a user ID. So within the first table, let's go back to the user table. This to, for example, that needs to reference an actual person. It needs to be actual data within that second version of the user table. And it's going to go to the second version of the user table, find that person with the ID of 2, and it's going to take that email and display it right here. So hopefully that makes sense, guys. And of course you can mess up this query. You can just mess around with it and put your own stuff in it to get your own results. And you can even change this statement right here to get even more crazy results. So yeah, guys, thanks for watching. Peace on Earth, and catch you in the next video, and subscribe. As well as v1.lastname and It's a 1, not an L, moron. For the aliases of the table, we're going to tell MySQL, oh, crap nuggets. I mean, it's not MySQL's database.